Hey, so now we're going to look at the next two exponent rules. So the next one deals with negative exponents. So it's real quick, try to figure out where negative exponents could come from. And we kind of could see this in the last video. When I divided, I went ahead and subtracted the exponents, and I subtracted them toward the largest exponent. So say instead of x squared, I wrote x cubed for some reason, but say we had x to the fifth over x cubed and x cubed over x to the fifth. We already said that x to the fifth over x cubed is x squared. You divide toward the largest exponent. We said you don't really need to write it over 1. You can, but there's no real good reason. Same thing with x cubed over x to the fifth. We already know that. We say it's going to be x squared. It's going to be x squared on the bottom. This time we do need the 1 there, as that does make a difference. Say instead we had gone backwards. Say just for fun we decided to divide them to the wrong side of the fraction bar, so subtract them to the wrong side of the fraction bar. If I did that, I would get x to the fifth over x to the I would get 1 over x to the negative 2. If I did that over here with the x cubed over x to the fifth, I would get x to the negative 2 over 1. This 1 over x to the negative 2 and x squared over 1 are the exact same thing. This x to the negative 2 over 1 and 1 over x squared are the exact same thing. They equal the same thing. What that means is that negative exponents are just on the wrong side of the fraction bar. Their base is on the wrong side of the fraction bar. So negative exponents, you want to flip the base to the other side of the fraction bar. So over a fraction. So let's do a few. And really, negative exponents are useful. A lot of times we don't want fractions, and especially when we're working with logs or with exponents, it's easier to get rid of fractions that way when we're working with deriving and integrating. It's a way to get your numbers, your expressions out of a fraction without having to clear something. You can go ahead and use negative exponents. But right now we're just going to get used to seeing them and get used to using them. So say I have something like 3x to the negative 2 y to the 3 over 5 x to the negative 7 y to the negative 8. Okay, so first thing I'm going to do is flip all my negative exponents. So all my bases I have negative exponent. So I have 3 bases on top. I have a 3, an x, and a y. My 3 has an exponent of 1. I didn't see an exponent, so I know it's 1. So I have 3 to the 1, that's a positive exponent, so it's where it's supposed to be. X has a negative 2 exponent, so I'm going to flip that over the fraction bar. Once it flips, it's now in the correct space, so it's a positive 2. Y has a positive 3 exponent, so I'm going to keep that where it is. My denominator, I also have 3 bases. 5 has a 1, that's positive, so I'm going to keep it where it is. X has a negative 7 exponent, so I'm going to flip that to the top. Now it's in the right space, so I'm going to write it as a positive 7 exponent. Y has a negative 8 exponent, so I'm going to flip that to the top and get y to the 8. Now I can just simplify the same way I was doing in the previous video. So 3 over 5, I can't simplify, so it's just 3 over 5. My x's, I have x to the 7 over x to the fifth. That means I am dividing, so I'm going to subtract my exponents. My largest exponent's on top, so I'm going to get x to the fifth. Got y cubed and y to the 8, they're both on top, so they're being multiplied. So I'm going to add the exponents and get y to the 11. That's it. So let's try another one real quick. Say I have something like 4x to the negative 3, y to the negative 6 over 2 x to 7 y to the negative 5. How's that? So again, I'm just going to start by flipping anything that has a negative exponent so I can see what my operations are really. So my 4 has a positive 1 exponent, so I'm going to keep that where it is. My x has a negative 3 exponent, so I'm going to flip that to the bottom, write it as x cubed. My y has a negative 6 exponent, so I'm going to flip it to the bottom and write it as y to the 6. Okay, so my numerator is done, just like my denominator. My 2 has a positive 1 exponent, so I'm going to keep that where it is. My x is 7, positive exponent, so I'm going to keep that where it is. y to negative 5, that's a negative exponent. So I'm going to flip to the top and write as a positive exponent. So I got 4y to the 5th on the top, 2x cubed, y to the 6th, x to the 7 on the bottom. Now I'm just going to simplify each part. So 4 over 2, 2 goes into both of them, it will be 2 over 1. My x's, I got x cubed and x to the 7. They're on the same level, so they're being multiplied. So I will get x to the 10. My y's, I got y to the 5th over y to the 6th, my highest exponents in the bottom. So I'm going to subtract them, and I'll have y to the 1 on the bottom. I don't need to write the 1, and I actually don't need to write the 1 in front of the x to the 10. So I should just have 2 over x to the 10 y. Okay, let's look at the fourth exponent rule. What happens if we raise a monomial to a power? So first we should define monomial. Monomial is something that has only one term, so has no terms are separated by pluses or minuses. They're products that are separated by pluses or minuses. So one term means no plus or minus in your expression. You can have negatives, but you can't have something being added or subtracted to each other. We've only been dealing with monomials in this section, so not really coming up so far. So 3x to the 5th, how about y to the 7? Say I was going to cube that. Well, that would be a monomial, no plus or minus. I'm raising it to a power. So I'm going to go ahead and write it out. I know what powers mean. That means multiplied by itself that many times. So 3x to the 5th, y to 7. 3x to the 5th, y to 7. 3x to the 5th, y to the 7. Okay, I can multiply common bases. I've done this by now. So 3 times 3 times 3 should give me 27. X to the 5th, x to the 5th, x to the 5th, add them. I'll get x to the 15, y to 7, y to 7, y to 7, add them. I'll get y to 21. So what would have been a faster way to do that? Faster way to do that, I can see it with my variables pretty easy. If I had just distributed my 3 to my x to the 5, I'd gotten 15, multiplied. Distributed, meaning multiplied it. Same thing to my 7. How would I gotten 3 to give me the 27? Well, all I did was cube it. So if I distribute it to, again, that one exponent that's right there, I would have gotten 3 to the 3, x to the 15, y to the 21, which is what I got. 3 cubed is 27. So when I raise a monomial to a power, all I'm doing is distributing the power to all the exponents. So let's try another one. Say I have something like 2x to the 6, y to negative 7. We'll throw a negative in there because it's fun. That raised to the, let's do 4th power this time. So this time, instead of writing it out 4 times, because that's going to get tedious, I'm going to go ahead and distribute that 4 to all the exponents. So I distribute it to 6, I distribute it to negative 7, and I also distribute it to that 1 that is right there with that 2, with my 2. So I'm going to get 2 to the 4, x to the 6 times 4 is 24, y to negative 7 times 4 is negative 28. I want to simplify this if I can, and I'll tell you now, you never want to leave negative exponents in your answer. I'll even write that up here. Do not leave negative exponents in your answer. It would help if I could write faster. Okay, so we don't want to leave negative exponents in the answer. That means I know I'm going to want to flip that y to negative 28. So if I flip that, I'm going to draw on a fraction bar. It was over 1, so it already had a fraction bar. We just didn't have to see it. But I'm going to get y to 28 on the bottom, x to 24 on the top, and 2 to the 4 I should be able to figure out. It's just 2 times 2 times 2 times 2. So it should give me 16. That's it. Let's do one last one where I combine a bunch of stuff. So what about 3x and negative 2, y to the 4, whole thing to negative 1 over 5x to the 7 y to negative 3. That squared. Sounds good. Should be long. So we'll start it off. And I'm going to start off the same way I started it off previously when we had multiple parentheses. I'm going to get everything out of parentheses first. So I'm going to take that negative 1 and I'm going to distribute it to all my exponents. Again, I'm going to write a 1 next to my 3 there. So I'm going to get 3 to negative 1. I don't get a negative 3. It's that exponent that's negative. X squared, y to negative 4. On the bottom, I'm going to do the same thing. Distribute that 2 to all my exponents. Again, I'm going to write that 1 next to that 5. So I'll get 5 squared, x to the 14, y to the negative 6. Okay, so now I'm going to flip all negative exponents. So in my numerator I have 3 to negative 1. So that's going to come to the bottom and be 3 to the 1. X squared is positive, so that stays. Y to negative 4 will flip to the bottom and become y to the 4. My denominator, I have 5 squared. It's a positive exponent, so it stays. Might as well simplify it a bit and write it as 25. X to the 14, positive exponent, so it stays. Y to negative 6. That's negative, so it's going to flip to the top. Now I just need to simplify like terms. So my numbers, 3 to the 1 is 3, and 25. They're being multiplied. This is 3 times y to the 4 times 25 times x to the 14. So 3 times 25 would be 75. My y's are being divided. My largest exponent's in the top, so I'll subtract toward there and get y squared. My x's are being divided. My largest exponent's in the bottom, so I'll subtract toward the bottom and get x to the 12. And I'm done. One thing you want to check for when you're doing these is that you end up with a single x and a single y. If you have more than one x or more than one y, you can probably simplify a little bit better. Okay.